In this video, we will configure persistence using cookies to keep track of the client source and making sure that the client stays connected to the same server they initially connected to and not load balance to a different server in the pool. Okay, so right now we have our server load balance configured using the method of least connections. So let's confirm if everything works before we do get started. So let's bring up a session. Running some more connections here. Okay, that is completed. And let's refresh our stats. Okay, so right now we have a total of 100 connections that is reaching our pool, and they were evenly load balanced between all of our servers with 25 connections each. Now, once we set up persistence, we will only see connections to one of these servers, which we will test again from our computer, which is acting as our client. Let's go ahead and clear the statistics before we get started. In order to set up persistence using cookies, you must associate profiles to the virtual server so the BIPLTM appliance can be able to view the cookies that will be used. So let's go to our virtual server page on our appliance. Okay, and let's go into the configuration of our HTTP virtual server. And there, under configuration, let's move down a little bit here. This will list the different type of profiles that can be associated with the virtual server. So to understand this concept better, think of profiles like instructions that the BIPLTM appliance and this virtual server can use to understand the traffic for each connection better. So for example, when we were testing web connections to our pool, the BIPLTM was only looking to the TCP header of the packet and looking at the port number, which is port 80, which we see here, and nothing more. It is not looking at any of the application headers because it doesn't know how to do that. It wasn't taught how to do that. Well, that is what profiles actually does. And cookies are associated with HTTP requests and HTTP headers. This is now getting into the application layer, and that will require our BIPLTM appliance to understand and to inspect HTTP requests. Now, HTTP is a TCP protocol, so we need to enable two profiles, one for TCP and the other for HTTP, in order for our BIPLTM to understand and to inspect cookies to do persistence. As you will see, the TCP profile is already enabled, which makes sense because this is how our virtual server knows to accept client requests when they initiate a connection to the virtual address using port 80. Next, under the HTTP profile, we will select the default HTTP profile that is listed here. And let's go ahead and let's apply our changes. Let's go down and say update. The next thing that we need to do is enable persistence using cookies, since our BIPLTM knows how to inspect HTTP requests now. And that can be done by going to the Resources tab for our virtual server. And here under the default persistence profile, we will select cookie. Okay, remember, this is only applicable for HTTP applications. If you're using an application that does not use HTTP and cookies, this persistence type will not work. So just keep that in mind. Okay, that is all that we need to do. So let's go ahead and apply our changes. We are now done with our configuration. Now, before we start testing, let's go back to the pool statistics page and local traffic and pools. For testing, we cannot use our tool for my Mac because it won't generate any cookies. So let's bring up a separate web browser. And from there, let's try to access the web farm. Okay, and we are connected to server 2. So let's run a few more connections to it by doing a refresh. And as you can see, that we are still connected to server 2. Let's go ahead and confirm that. Let's refresh our stats here. And there we do see that we were established to web server 2 and only web server 2. We were not load balanced to other servers. So the connection remained persistent to that single server only. Before we conclude, since we set up persistence using cookies, we know that the Big IP created a cookie for the connection that our computer used and installed. That means the cookie should still exist in the web browser of our computer. This is great for troubleshooting if persistence using cookies is not working. Well, it could be that cookies are not enabled on the client, or some web proxy is used at the client site. Hence, it is an issue on the client's network. Many websites today require cookies to be enabled, or access to that application or website could break. Now, in our case, we know that persistence using cookies does work based on our testing. So let's view the cookie that was installed. If you're using Chrome, you'll go to your settings, and then there under privacy, you'll go ahead and click on content settings. And there under cookies, you'll click on all cookies and site data. This will show all cookies that has been created and stored for each site that we have accessed. At the very top, you will see the virtual address of our HTTP virtual server. Let's view the cookie details for that entry. Okay, and that will show a lot of details that are familiar to us. For the name, it contains the actual name of our server pool, which we named pool_HTTP1, that is associated to this virtual server and address. The domain here reflects the IP address that we use in our browser for accessing our server farm. We even see when this cookie was created and when it will expire. Now for the content up here, it is encoded, and this is used by the Big IP for knowing which server in this HTTP1 pool to send client requests to. So again, viewing the cookie details can be very helpful to ensure that persistence using cookies is working as expected.